Good morning. I'm gonna try to make this video pretty quick. We really should be going over some vocabulary review and essential processes for adding and subtracting fractions with unlike denominators. So if it's okay if you forgot how to do this, we're gonna go through it together. So first we talk about unlike denominators, right? So if we talk about the denominators, those are the lower numbers. And the numerators are the top numbers. Numerators show us how much, and the denominators show us what size. Okay, so that's just a review of what fractions are and how they're made up. So we see that b is not equal to d, and that gives us unlike denominators. So when we're dealing with trying to add and subtract things, we have to make them the same. So with whole numbers, it makes sense. And with decimals, it makes sense because those parts in those wholes, the size are the same. Okay, so if we're adding tenths and decimals, they're the same size. So we're able to add them. But with fractions, these aren't the same size if the denominators are not the same. So we have to go back and revisit something called least common multiples. So the least common multiple of a number is the product of multiplying that number by another. Typically, when we're looking for least common multiples, we list the multiples in increasing order. So 3, 6, 9, 12, 15, 18, 21, 24. So the least common multiples of B and D, so it would be B, 2B, 3B, 4B. So we just keep multiplying by B, and it would be D, 2D, 3D, 4D, and we just keep going until two of those numbers were the same. So if I had another actual number, let's say 3 and 5, we list the multiples of 5, 10, 15, 20, until we see there's one similar. So the least common multiple of 3 and 5 is 15. So that's just a review of least common multiples. Okay, sometimes you have something called a prime denominator. Okay, so that means there is a prime number in the denominator, in both denominators, this time when we talk about our fractions. So the common prime numbers you're going to see in the denominators are 3, 5, 7, 11, 13, and 17. So if you see those numbers, then go ahead and multiply those together. So 11 and 13. You can just multiply 11 times 13. And you will get 143. And that will be your denominator. Yes, you're going to see denominators that are large. You will see them. And you work with them just the same way as if you had 2 times 3 and your denominator is 6. Okay? So don't worry about large denominators. Oops. Once we find the least common multiple or the least common denominator, we're going to look at creating equivalent fractions. So we have to make sure the denominators are the same after we create those equivalent fractions. So you notice the m is here and the m is here. But how did we get from b to m? And what does this prime mean? Well, when we're multiplying out, not only our denominator changes, but our numerator changes. So whatever we multiply by to get from b to m, so x, we have to also multiply a. Same thing here. Whatever we multiply to get from D to M, let's call that Y, we have to multiply C also. And we call that our form of 1. Okay? So in order for fractions to be equivalent, we must identify the property, we must use the identity property of multiplication, which is any number multiplied by 1 is equivalent to that same number. So 2/3, you make that equivalent to another number. Let's say I want to make it equivalent to 6. So what do I multiply 3 by to get to 6? I'm going to multiply 3 times 2. But I can't just randomly go multiplying numbers and expect to get the same result. It has to be equivalent. So I also have to multiply the numerator by 2 to get your equivalent fraction. 2/3 is equal to 4/6. Oh, I don't want to model it that way. Let's look at a bar model. Make sure that's true. So 2/3 and 4/6. That is true. We call this 2/2 our form of 1 because 2 divided by 2 is equal to 1. And if we multiply any number by 1, it's equivalent to that same number. So whenever you're converting to equivalent fractions, make sure you're multiplying the numerator also. Okay, so now we're ready to add and subtract. So you keep the denominator. You don't add or multiply or anything not together because that's how big the size of the piece is. And you add the number of pieces together. Or you subtract and keep the denominator. So we're going to go over some quick examples. Okay? So I have 2/15 and 5. So I know that 15 is a multiple of 5. 5, 10, 15. And it's the third multiple. So I know I have to multiply 5 by 3. First thing I'm always going to do is I'm going to rewrite it vertically. You don't have to. It helps me keep my work more organized. So we know that our denominator we want is 15. So I'm just going to rewrite this as 2/15. But I do have to make an equivalent fraction for 3/15. So I know I multiply it 1, 2, 3 times. So I have to multiply 5 times 3 to get to 15. My form of 1 is 3/3. So 3 times 3 is 9. 5 times 3 is 15. Add those together, and I get 11/15. And that's as simple as it is for this addition. The first thing you should do is understand what's going on. And we can do that by either drawing diagrams or writing equations. So let's see if we understand what's going on here. On a hot day, Mabel poured 2 and 11/12 of a bucket of water into a plastic wading pool. A few minutes later, she added another 4 and 1/6 of a bucket. How much water did Mabel pour into the pool? How much water? And I'm going to think all together or total. So I'm going to think addition. So I can model this. So 2 and 11/12. And then 4 and 1/6. So this is kind of like going to be my total. I can also write in equation, right? So total equals 2 and 11/12. plus 4 and 1/6. So my equation right here, this is my addition. That's what I'm going to do. So the first thing I'm going to do is rewrite it vertically. Now I can add the whole numbers now, but I'm going to implore you to wait and just keep carrying them over until we have equivalent fractions. Okay? So 2 and 11 twelfths, twelfths and 2, we need an LCM. Well, 12 is probably going to stay because 2 is a multiple of 12. So the LCM is going to be 12. So 2 and 11 twelfths, we're just going to keep. I'm going to multiply my form of 1. To get 2 to 12, I need to multiply by 6. So I'm going to keep 4 because I'm not multiplying 4 by 6. 4 just stays. I'm only multiplying the fraction by 6 to get an equivalent fraction. So 1 times 6 is 6. 2 times 6 is 12. Okay. Now I can add. Start on the right. 6 plus 11 is 16. Twelfths. 4 plus 2 is 6. Okay, so I do see an issue right now, though. 16 twelfths is an improper fraction. Okay, so when you're doing mixed numbers and improper fractions, either the whole thing has to be improper or none of it can be improper. So 16 twelfths, we need to make that into a proper fraction. Oh, it's 17 twelfths. There I go again. 17 twelfths has to be improper. So usually I can think and I can say, well, 12 twelfths is 1, so that would change it to 7, and then I have 5 twelfths left. I'm going to show you this computationally. So I'm going to separate out 1 12, 12 twelfths, 1 whole, from 17 twelfths. So it's now 6 twelfths plus 12 twelfths plus 5 twelfths. And now that 12 twelfths is equal to 1, correct? So now I have 6 plus 1 plus 5 twelfths. So I have 7 and 5 twelfths. Okay, 7 and 5 twelfths water. All right, and this is about lines, drawing lines. Kurt drew a teal line that was 2 1/3 of an inch long. Then he drew an indigo line that was 1 1/2 of an inch long. How much longer was the teal line than the indigo line? So how much longer again? And we are going to look at this. So 2 1/3. So this is the first line, 2 1/3. The second one is 1 1/2. So you know the second one is longer. So remember, on your papers, on your work, you do not have to draw diagrams. This is just for me to understand and to show you how this works. So we need to find out how much longer. So how much is this right here? Let's write our equation. 2 1/3 minus 1 1/2. Okay. Our least common denominator. Let's go 2 and 3. We could list multiples, but these are prime. So 2 times 3 is equal to 6. That's our least common denominator. Remember, when you have prime denominators, you can just multiply them together. All right. Now we want to rewrite these vertically. 2 1/3 is 1 1/2. Okay, let's get these to the correct place. So they both need to be multiplied by a form of 1. 2 over 2 times 3 over 3. Okay, so now I have 2 and 2 6 minus 1 3 6. So I can subtract. Well, I can't take 3 from 2, so I need to regroup this before I subtract. So just like when we're regrouping, when we're doing subtraction, we can regroup whole numbers into fractions. Okay, so but instead of going into tenths this time, I'm converting one of these 2's into 6. So let's see what that looks like. So it's 2. Oh, nope. I need to regroup one. So now I have one whole, and then I have 6, 6. Let's do 6. So that's going to be 1 and 8, 6. Okay? So just like when we take our answers, if we have improper fractions, we're kind of going opposite. So we're regrouping one of these whole numbers so that we can do the subtraction. And this remains the same. So it's minus 1 and 3/6. Now I can subtract. 8 minus 3 is 5, 6. 1 minus 1 is 0. So the answer is 5/6 of an inch. Okay, that's it. So you have like 10 word problems. If you needed help yesterday, hopefully this video helped you and you can go back and complete that work from yesterday.